Please welcome A.E. Natarajan.
Wow. Good afternoon. Are you guys awake? Yes, it's an amazing show. I know there are people who are still trickling in from the keynote speech, so we should have more of the folks as they come in. But it's been an amazing show. If you haven't heard it before, networking is core to everything that is going on in the AI era. You heard it from Rami, you heard it from Antonio. Networking is so critical for AI. With that, I want to tell you more about routing and what routing plays a huge part in networking. Following me, you will have the data center folks talk about data center switching. That also plays a huge part in this AI era. But more excited to share all of this with you. With that, let's take a look. How many of you traveled to come down here? Pretty? Almost everybody, right? Vegas is not where people go to retire. So if you're working, you travel here. Did you experience AI when you traveled here? I'm sure you did. At the airports, there was facial recognition. You probably scanned your passports if you're coming in from another country. You probably filled out e-cards when you're doing this. AI is everywhere in the mainstream. And we have been spending over $650 billion building all of these AI models in the back end to give you the capabilities to actually consume this AI, and more than 50% of it is adopted and it's in our daily life. Every one of you is using AI. And like Rami said, it not only generates a $4+ trillion value, it also is something that we have day to day be there, and it creates a huge impact into the underlying infrastructure, which is the network. Now let's take a look at what does it do to the network. AI does three main things with the network. The first thing we talked about, you heard Disney, he said petabytes of data. You have meta glasses, you have several other things, which essentially means the traffic that is going into the network is not unidirectional. Previously, you would click a Netflix movie, you would get 4K video down. But now, you would send rich video up, rich video down. You heard the hospital guys talk about how much video goes up and down. So the networks, both the upload and the download, is symmetric traffic. Not only is that symmetric traffic, it also is not cacheable. Previously, you could take a Netflix movie, cache it at the edge. It could be streamed a lot more easily. You cannot cache AI traffic. What happens if you do? In less than a few milliseconds, it becomes obsolete. It's invalidated. You cannot cache it. It's synchronous traffic. And last but not the least, some of us are probably still having jet lag, but do you think agentic AI sleeps? No, it doesn't sleep. It's awake. It's doing the digital twin. It's doing all of the transformations. What does this mean? This means the network has to be up, reliable, and perfect in everything and anything that we do. It has to provide the performance, it has to provide the security, and it has to cater to the growing needs of the demands of AI. I want to show you a slide where you have the enterprise networks and the service provider networks and the data centers. This is all of the networks that you can see. I'll leave you with one thought. If you have a network, you have a router. It is a must. Take a look at the enterprise network. With AI, they no longer can rely on running their applications over SD-WAN because it doesn't give you the throughput and the scalability that you need and the latency and performance. So you need private WAN. With AI data centers that you're building within the network, you need to connect these GPUs within the data center and across the globe into AI data centers for either training or for AI consumption. And you need the routers right there and then. Just remember one thing. If there is a network, there is a router. 4 different use cases. The first one, AI data centers, where you're doing all of the training, where you're doing all of that inference, and everything that you've been doing there. Second, we all know that GPUs don't operate isolated. You have to cluster them and connect them together. And when you cluster GPUs together, what is the biggest thing that happens? You don't have enough power in one place, maybe not enough space. You have to geographically distribute it. And when you geographically distribute it, you have to connect them together. And that is where the second use case of data center interconnect comes into play. And this is critical and important because people spend a lot of money building these data centers and GPUs. These interconnects have to give that level of performance with the data coming in when it needs to be so the GPUs are not starved waiting for data. That means they're losing money. So the data center interconnect is critical and important for us. The third one is AI consumption. When you actually do inferencing or consume AI, it is driven to the edge. You have applications, agentic applications, also your own interactive AI that needs to be serviced at the edge. Some of these applications could be latency tolerant, but then many of the applications, like what you heard in the medical field and other places, they are not latency tolerant. They require the security. So a distributed edge inferencing is critical for us in this networking world. And there is a router that plays a huge part in the inferencing. Last but not the least, you have to have AI security embedded across the entirety of the network. Let's take a look at how we build this. You probably saw it in Rami's slides. We build it all the way with our silicon, with our systems, and with our software. But we use 3 important principles to build that. The first one is sustainability. What do we mean by sustainability? The one that uses the lowest power, the lowest space, the most compact router that you can think of, and has a longevity that once you deploy it, it is scalable and it manages itself for the growing and changing needs. The second thing that is most important for it is the performance. Today's demands are 800 gig 1.6T. Tomorrow's demands are 3.2T. Disney said they have petabytes of data for a movie. They're going to have multiple hundreds of petabytes of data for the next movie because of AI, because of all of that. And medical data is even more huge. So performance matters in terms of pushing this data through every aspect of it. Last but not the least, you need automation. If it is not easy to deploy, it is difficult to consume it. You heard self-driving networks. It is not just a concept. It is a reality, and it is mandatory that we have self-driving networks that can drive this network in the AI era. With that, let me show you what we do. We constantly innovate through this process. We have built the performance. We were the first in Juniper to build the 40 gig, the 100 gig, the 200, the 400, now 800 and 1.6T, and we will be there with 3.2T. As you change and put a lot more denser systems and you build on top of it, power efficiency and sustainability, I talked to you about it, is critical and important. New innovations in terms of how we consume power, how we cool it, and how we manage it with air-cooled and liquid-cooled technologies is critical and important for us. And we will continue to innovate on that front. Last but not the least is the tools. It's agentic AI, AI nativity. And I will show you a little bit later of how we progressed through this automation. What do? We actually have purpose-built products that do this from the silicon to the system to the software. And we have the ACX, the MX, and the PTX. And these are built with our own silicon, the ACX with commercial silicon, but the MX with our own Trio silicon. Have you guys seen the Trio silicon? It is in the 7th generation of silicon that you can have, and I carried it in my pocket. Okay? Unbelievable. It's 3 nanometer, and it's the 7th generation. We have packed so much innovation through the years with this silicon. And guess what? We have the PTX with our Express silicon. I'm not David Copperfield, but I do have a PTX in my pocket. Woo! The PTX. Amazing chip. 6th generation going on, right, guys? Amazing. And it does 800 gig, and it'll do 1.6T and 3.2T as we go through it. These chips have everything that we need with those 3 fundamental principles that I talked about: sustainability, performance, and the automation capability and the telemetry capability that is built in all the way from the silicon to enable us to build products and solutions for this AI era. And based on this, we also know that people need a portfolio of products. Okay? And guess what? We have that. We have the large router. If you haven't seen it, you just need to walk all the way back into the networking area. The most compact, largest router that you can see with 54 ports of 800 gig right there on the PTX front. We also have the smallest routers. And we have the medium. It's not just t-shirt sizing. People ask for extra large, extra large, medium, extra medium, whatever you can think of. And we have the combination that really, really builds it out to give you a full portfolio that can cater to every aspect and every need that you need to go through. That is the power of what we build with our silicon, with our systems, and our software, which we have been iterating through the years, is robust, most scalable, highest performing software that you can think of. We have won awards everywhere, including the recent awards from Interop in Tokyo. In EANTC, we actually have a bake-off, and we have the best performance in our software across every competitor that you can think of. Truly amazing innovation and a great place to be. Like Rami said, if you have to win in this AI era, you need to have the right infrastructure. And to build the right infrastructure, you need to have the right products and solutions. We have the best solutions in routing that you can ever get across the industry. Now let's talk a little bit about automation. I actually have a little bit of a history lesson. I think Kiriti was somewhere here. About 12 years ago, he dreamt about this concept called self-driving networks. And he started there, right there in the front row. And the reason why he thought about the self-driving networks, I was asking him, is because he said, hey, Juniper, we invented telemetry with model-based telemetry, Yang, NetConf, all of those things. This is so rich that we can take this data and start to build insights. And guess what? With these insights, we can build some advanced heuristics and correlation and do some actions that is the genesis of building something that is automatable and built on top. With that, you do some recommendations. And then on top of these recommendations, what you do is you bring a man in the middle or a human in the middle. I think you had an example a long time ago where he asked a question to people. Would you get into a car, a self-driving car, without a steering wheel and a brake? Right? 6, 7 years ago, people will be worried about it. Some of you should try the Zoox over here. It doesn't have a steering wheel and a brake. There's no man in the middle, but it is self-driving. Not everything can be self-driving. It is human-assisted, moving all the way to self-driving and self-driving networks that we're building. This is a journey, and we are proud to say we've constantly innovated, and you've seen several demos that show how we build on top of this to make this a reality. So today, with our products and solutions, all the way from servers, storage, to networking, to routing, to long distance, to short distance, within a data center, outside a data center, at the edge of the network, with peering, with core, with everything, you have this capability in your hands. And HPE is the one and only company that has the full stitched portfolio that can give you this. With that, I would like to bring on stage Deepika, who's going to show you a demo, a real life demo, because it is true that we have self-driving. Come on, Deepika. Are you ready? Go for it.
Thank you very much. Glad to be here. Hello, everyone. For the next 15 minutes, let us put ourselves in the shoes of a NetOps manager who is preparing for a major event. Let's say you're running NetOps of a global retail company, and you're preparing for your annual sale event. So from tomorrow 8 a.m. onwards, for exactly 10 hours, the traffic is going to surge across all of your stores, data centers, as well as your cloud apps. So as the NetOps manager of your company, it's now your responsibility to troubleshoot every single trouble ticket that comes your way relentlessly for those 10 hours as fast as possible, right? What if you didn't have to? What if you could avoid having those trouble tickets in the very first place? With HPE AI native automation, now it is possible. Let me show you how, step by step, by taking you through 3 distinct phases: sense, reason, and act, all powered by our cloud-delivered HPE Mist routing assurance. Let me start with the very first one, sense. Traditionally, network operators get overwhelmed with thousands of telemetry points across all of their routing infrastructure. It could be CPU, memory, interfaces, routing events, protocol states, so on and so forth. But the real challenge is not in collecting all of this information. It's in understanding what this data really means for your entire network experience. Routing assurance solves this with the help of what we call as the service level expectation or expertise. Let's take a look at that. SLEs continuously aggregate and analyze data across all of your routing infrastructure. Let's take an example of a router health here. With a single click and a single decisive indicator, you can now tell if the router is in a good health or not. Looking at the router health SLE, it is correlating reams of data from CPU, memory, fans, temperature, so on and so forth. Here, again, with a single click and a single decisive indicator, you can see if your router health is in good condition or not. And if there are any issues, you can simply double-click and look at all the affected items. You can further go ahead and look at what issues are getting contributed into your network. And then we, of course, also have our synthetic twins that is running synthetic traffic across your network. It runs synthetic traffic with or without users before or during production hours to check the quality of your network. So on one hand, you have the synthetic twins that is measuring the quality of your network, and on the other hand, you have the SLEs that is measuring the health of your network. Put both of them together, and you have the most meaningful visibility into your network, which is absolutely table stakes for proactive assurance. Let's go to the second pillar now, which is reason. With the first pillar sense, we were, of course, able to identify the issues. But should an issue really occur in the network, you got to fix it. And to fix the issue, you need to know why the issue actually occurred in the network. Any manner of events could be happening in the network: routing instabilities, routing inconsistencies, congestion, latency, power failure, cable failures, DDoS attacks. And this is exactly where Marvis Actions becomes incredibly powerful. Let's take another example here. Here, our synthetic twins have identified a series of network failures. To understand why this failure occurred in the network, or any failure for that matter, you simply go to Marvis Actions. Marvis Actions is like that experienced network engineer who is constantly looking at your network, identifying and troubleshooting issues. You simply browse through the Marvis Actions, look at the open items, and look for more information. And you get everything you need to know to understand why an issue occurred. Let me take an example that most network operators dread: a traffic black hole. When a traffic black hole occurs in the network, traditionally it can go two ways. It can go the hard way, where users start experiencing slowness, failures, anomalies. They start complaining, you start troubleshooting, but you go nowhere because the hardware is all green. Or it can go the Marvis Actions way, which is the easy way, where Marvis Actions has a very easy way of correlating your telemetry data, your routing information, as well as your forwarding path, and alerting you if there is a potential black hole. You see, here's an alert: traffic drops. You click on that and look for more information, and you get every information you need to have to understand why a black hole occurred in the network and what you need to do about it. So with Marvis Actions, you simply cut off all the noise, and you focus only on what really matters now. If you want to know more details on what else is going on in your network, you can simply go to Router Insights. Router Insights provides you with a bird's eye view of everything that's going on in your network, including all the routing events. So you simply look at that. Here, in this particular example, a user has made a certain configuration change at a certain timestamp, and you can see that. So putting it all together, what used to take hours of troubleshooting after an issue occurred can now easily be remediated even before somebody really notices it. Let's take another example here, another capability of Marvis Actions. Let's go to Marvis Actions, and let's look at this example of congestion. Let's look for more information, as always. And let's pause here for a while and really appreciate what we are seeing. What we are seeing here is not a notification that came in after the router congestion occurred, but it's actually a prediction that the router congestion can occur in the network. And it's even giving you some remediation actions, like you can do some capacity upgrade, or you can do some path optimization, or even a policy change. So now, by collecting all the link utilization data and applying an AI algorithm, you can easily forecast and predict and tell if your links are getting overutilized. So with Marvis Actions, not only can you do the root cause analysis of problems, but you can also do predictive analytics in your network. Moving on, with sense and reason, we were, of course, able to identify issues, and we were even able to look at the root cause of the problem, even do some predictive analytics then. Half the battle won already. But to win the other half of the battle, you got to fix the issues. And to fix the issues, we have to act upon it. Again, Marvis Actions has another brilliant capability here. Not only does it find the root causes of the problems, but it can also fix the issues. Let's take an example. Marvis Actions has identified a missing prefix. Somebody made a configuration change, a preferred prefix went. But it's not just stopping there, it's even providing you with the exact CLI that you need to push into the router to fix the problem. You can simply review and approve the changes, and there you go. Your issue is resolved. If you really want to make sure that everything is working fine in the network again, you can validate by going to the synthetic twins and running that synthetic traffic. Now you see everything is back green in the network. So with sense, reason, and act, you can now avoid having those trouble tickets in your network at the very first place. Whatever the issue may be, a congestion, latency, routing inefficiencies, misconfiguration, routing assurance has an easy way to transform insights into actions and helps you resolve issues faster. Let's again now go back to our NetOps manager, who also has to deal with large WAN networks. WAN networks today are facing incredible amount of demand coming from AI services. Every company wants to have their own AI models in-house, for which they need some training, they need some fine-tuning, maybe even some inference capabilities like having a virtual AI assistant, an agentic AI, so on and so forth. But this is also adding some extra pressure on NetOps managers because now they have to provide path optimization and even network lifecycle management. To support this, we have HPE Routing Director, which provides you with the complete network lifecycle management starting from planning, orchestration, assurance, and even optimization. So in the next few minutes, let's see how Routing Director helps in breaking complex tasks into simple and streamlined ones with the help of agentic AI, with AI acting as your tireless assistant. Let's start with the very first one, which is planning. Let's say you need to add a new AI data center into your network. And to do so, you have to make sure that your network is capable of taking that extra expected 10 Gbps traffic in and out of the data center and to the connected sites, the users, and everything. What do? Very simple. You simply go to your agentic AI framework, open your AI chat, and you put in your request. You can simply say, hey, I'm bringing this new AI data center, connect to New York City, 10 Gbps traffic, help me. It's doing all the hard work for you and giving you it's actually saying no, but it is also giving you some suggestions that you might want to consider to actually make it happen. Let's see here, it is saying now you can either upgrade your links from 10 Gbps to 100 Gbps to get that extra headroom. Maybe you can do some rate limiting. Maybe you can do some load balancing, or you can add a dedicated dark fiber into your network. You can pick up any of those options, and you can do further network planning. Routing Director provides you with a very comprehensive network planning tool by means of which you can take a snapshot of your entire live network, or any network for that matter, and have a replica of it. In the offline mode, you can go ahead and add and modify devices, add links, whatever you want. You'll have the complete visibility into your network, and you'll see every detail in the network. For example, here you can see links, demands, interfaces, whatever you need to know. If you also want to do some failure analysis, some simulation, to see, to pressure test your network, you can simply go to your exhaustive failure simulation mode and do whatever type of analysis you want. Here, we are going to our exhaustive failure simulation mode, and we are typing in our request, which is basically we are adding an extra node. We could do some link failure analysis, and Routing Director takes care of every type of link failure analysis. A single link failure, double link failure, thousands of scenarios are executed, and it provides you with detailed results. If you want to know more details on anything that you want to know about your network before you actually put it into production, test, pressure test, look at risk points and everything, you can simply go back to your AI chat assistant and ask whatever question you want. So this way, whatever changes, modifications, or optimizations you want to make in your network, you could do it beforehand and keep your network ready for whatever you're going to throw at it. Now, let's take another example, another orchestration capability, onboarding routers into the network. Everything in Routing Director is managed centrally. So onboarding routers is made very simple. All you got to do is simply connect the devices physically, and as soon as you connect the devices physically, Routing Director automatically detects them and onboards them one by one, step by step, publishing all the success criteria along the way for you. So it's very simple, made very easy. Now you see how you can onboard all the routers into your network. Roughly takes about 10 to 15 minutes, and your extended network is made ready. Finally, let's talk a little bit about the assurance and optimization capabilities, which is absolutely necessary for self-driving networks at a routing layer. The fact of the matter is that we do not really have everything that goes on in network under our control. Again, there could be link failures, power failures, cooling issues, so on and so forth. But Routing Director provides you with full resiliency to the inevitable. If there's a link failure, a node failure, a latency, a traffic spike, whatever the issue may be, Routing Director has the complete visibility of your network, and it autonomously reroutes your critical connectivity around the problematic devices or network areas so that your traffic is stable and you don't face any issues. Surely, we cannot predict a lightning strike or a pipe burst or a power failure, but we can help you mitigate the impacts by providing you with remediation and allowing you to fix the issues, knowing that you're not in a crisis mode. All right? With that, we have our routing assurance with sense, reason, and act. Now you can avoid having those trouble tickets at the very first place. And with Marvis AI by your side, you can simply focus on what really matters to you now. And with Routing Director, you have the complete ability to do the network lifecycle management, starting from planning, orchestration, assurance, as well as optimization. And along with MCP Server, now your simulation and analytics is made even easier with natural language prompts. With that, let me call upon Sunil to take the session forward. Thank you.
Stay here. Only she would have told me this 20 years back, I would have not done the CCIE, right? Marvis can do everything. 20 years too late, but thank you.
Here, a clicker.
Good afternoon, everyone. I don't think I need a clicker.
Okay.
My name is Sunil Sudani. I'm part of the product management team. I'm super excited today. You know why? I don't have to tell you anything today. Today, I have to listen. I'm going to moderate a panel with our distinguished guest to hear from them what is their perspective on the AI. How many of you attended the Rami's keynote? Just raise of hands. Almost all of you. Rami mentioned something. Routing has never been more critical than now. Why is that? A lot is going on in the AI infra build, but it is more focused on the compute, GPU, storage, data center fabric. I think there's less attention paid to this critical component of routing. But as AI starts getting consumed, you will see this will be the biggest gate. So, without further delay, let me invite our guest here on the stage. Let me start with Yichen Kai, VP of Engineering from Microsoft. Please. Welcome, Yichen. I think we can give credit to Microsoft for bringing the AI to the mainstream, right? Please, anywhere is fine. That's good. Okay, next up, Francis from Lumen. Welcome, Francis. And we have tasked Francis and his team to build the AI highways to connect Microsoft to the consumers. Next up, Stephen from Akamai, Senior Director, IP Networking. Welcome. Now, Akamai is not unknown, right? In the cloud era, they played a key role, right? And they're extending that to the AI era. Welcome. Now, the next up, Alfredo from Sabre. Welcome. Without Alfredo, none of us have a job because he consumes the AI. Welcome. Please. Last, our own HPE Networking SVP GM, routing infrastructure. Come on in. You need a clicker?
No, we don't need.
Okay, let's get this party started. Okay. I don't think I did the justice introducing you guys. Why don't we start with a round of introduction? And how does your day look like in the AI world today? Starting with you, Yichun.
Okay, all right. Thank you. Hi, everyone. Very nice to be here. My name is Yichun. I'm a vice president at Microsoft. My day job, I essentially have 2 day jobs. I run the Azure Wide Area Networking team. So everything that comes in and out of Azure, and then everything that gets exchanged between Azure is managed by my team. In the meantime, I also, in Microsoft, as part of the Wide Area Networking team, I support the large build-out and an operation of the networks that support all Microsoft and our key customers, AI training and inference networks. So,
Thanks,
Thank
Yichun.
you.
Hi, Steve Schechter. Thanks for having me part of your panel. So with Akamai, responsible for network engineering and architecture of the platform, you know, we're part of the same class. I think Juniper and Akamai IPO'd the same year.
Yeah?
Yeah, which is awesome. But, you know, the OG CDN with a pivot to security and now into compute. So we're using our highly distributed edge infrastructure to support, you know, critical applications at the edge now.
Awesome, thanks. Let's hear from you from Sabre perspective.
Hi, folks. Alfredo Rodriguez here. I lead Sabre's infrastructure and cloud teams. I get to lead a great bunch of folks in the travel and hospitality industry, specifically building the infrastructure that probably many of you here in the room use to travel here today. It's all built on Juniper. And what we're doing day in, day out is preparing for that next generation of agentic AI travel solutions.
Awesome, thank you. Last but not the least, the AI highway.
So yeah, I'm Francis Ferguson. I'm a distinguished engineer for Lumen, and I'm responsible for the architecture of the networks that we have. We've got a few of them, right? But we've got the internet one, separate network, and we've got the MPLS private network. The private network was recently upgraded with Juniper MXs to be a multi-terabit router, all 400 gig, using things like routed optical networking. If you're familiar with that, OpenZR+, all those things are built into it to scale out the network. And that's really where we're going to put our enterprise AI customers onto that to connect into the hyperscalers, the clouds. That's our goal.
Thank you. I'll skip A because he introduced and also he's my boss. So I'm going to skip him for this pressure of introducing one more time. So why don't we get right into it, right? I'll start with the common questions for all of you, right? It's a simple question. How is AI changing your network and infrastructure strategy for next 3 to 5 years? And what are the biggest architectural shift you are planning to do? And again, if you can focus on the routing part and the data center part, that will be good since this session is about routing. Why don't we start in the same sequence?
Okay, great. Very good. Thank you. First of all, I would extend routing into both routing and traffic engineering. I don't think you can actually separate routing from traffic engineering in today's wide area network, especially in today's networking that connects data centers and then connect to your users over to the internet. So in my daily life, I think AI does have a very, very big impact in 2 areas, right? One is how we design the network and how we architect the network better, because with the introduction of the AI, the workload changes. And then the workload placement changes, which means that the routing and the traffic engineering infrastructure will have to change accordingly. And we'll have to respond much faster to the workload changes and their placement. Both are extremely important. And then we can probably get deeper if get a chance, right? So that's one part of my job. The other part of our job is that how we operate this network so that after design, the advantage of the network can always be maximized, and then the weakness can be sort of hidden a little bit or can be overcome, right? So the AI will actually play an extremely important role for us to determine the paths to go in each of those directions. So I'll probably leave it to Steve.
Your perspective.
I would touch on some of the physical constraints. We're seeing large data centers now that might be outside of a critical mass of connectivity and your traditional providers. And, getting there is certainly challenging. Getting the right level of connectivity, the right level of diversity there, and then even power constraints. Right now we're trying to build it faster, bigger, but we're limited by the amount of available power. And, we need more efficiency in the pluggable optics and in our routing and DWDM core to fit everything and be able to provide, terabit scale, petabit scale infrastructures.
Awesome. So the bandwidth constraints continues to remain challenging, and the highways, which we were talking about, the Lumen is trying to build to connect you to the end user, is still limited in the capacity, and that's what you'd like to see. But from your perspective, as a user of this AI,
Yeah, I mean, we also build AI solutions for the travel industry, right? So I think what we're seeing is a shift in the kind of traffic flows that we're seeing. Historically, we've always seen a lot of API traffic, right? From all over the globe to ticketing systems, travel agent systems, booking systems. But now with the era of AI, we are building out our own MCP servers as we're preparing for travel agencies and airlines to really engage with us using agentic flows. And that's changing the nature of the traffic flows, right? Instead of small API calls, now it's much larger, MCP driven, a lot more upload, like you mentioned earlier. And it's causing us to really rethink about what the capacity needs to be going forward, how we utilize the services and the capabilities of the Trio chipset and the MX routers that we have on site. And now we continue to kind of stay ahead of what the industry is asking of us.
awesome, thanks. From Lumen perspective,
So a couple of things I would say. First of all, it starts with the fiber for us, right? So building a national network requires intercity fiber. So Lumen has invested significantly in that over the last few years. We'll continue to do it. We've got about 100,000 route miles of fiber. That's the connected paths. But then we've got 17 million fiber miles.
wow.
Who wants those? Some of these people over here want those, right? In other words, you need fiber to build a network for AI. That's step number one. Then we need big transport, preferably routed optical networking, OpenZR+. They're really efficient. We're not there today on intercity, right? We're targeting 800 gigs. We've tested the PTX with 800 gigs between Denver and Dallas last year. But most of the network we're building right now is around 400 gigs. Yeah. Next year, it'll be 800 gigs. The years after, 1.6. So we really have to follow the transport side. We can't just build routers. So our MPLS network today is all built on MX 10K4s, right? N by 400 gigs. Now we're also then taking that and pushing it into the data centers directly to where we've got our on-ramps for the cloud partners. And recently we announced a partnership with AWS and with Google around what they're calling interconnect last mile. That allows customers or enterprises to dynamically get there literally in seconds. It's all API driven, standard APIs to Amazon and Google, so customers can turn up the services in literally seconds. So that's where we're going.
That's awesome. I see a possible deal here, right? In the back, let's go backstage to that deal. Hey, from your perspective, what are you hearing from the other customers worldwide from the global perspective?
So very interesting, right? I mean, for the first time, I don't think we rehearsed it. I heard from you guys. We're hearing similar things from every customer that we can think of. Customers are talking to us about how they need to build their network capacity 10x in the next 5 years compared to the 10x that they built over the last 20 years. So the amount is changing. And the requirements and the demands are changing constantly. But some of the themes still come back to the fundamentals that I talked about earlier. Eachin mentioned about traffic engineering. We have Giridi here working on multipath traffic engineering that can actually enable AI native traffic engineering capabilities and innovate on top of it to help out on many of these aspects. So we work very closely with that. Steve, you talked about power, and I talked about sustainability. I can proudly say that our current chips were the ones that was actually selected by one of the customers who wanted to build data centers in space. I'll leave it at that. And the reason is, in space, your power is going to be the lowest. You don't have capabilities of generating it, but you also have to surround it with a lot more intrinsic technology to space harden it against everything that is happening out there. So we will continue to innovate on our sustainability story and our power story that we've been talking about. Last but not the least is the capability to actually spread out and scale up, which you have been mentioning in Lumen. And I think that goes a long way to how we continuously innovate in terms of our speeds, feeds, capability, performance, our throughput latency requirements. Think about it. It's critical and important that we move data from one place to another as fast as we can so that your applications, your MCP engines, your agentic AI can really work without latency, without any of those things. And we will continuously strive to drive those innovations in our products and solutions, all the way from silicon systems to our software. And that is critical and important for us.
Thanks, A. Let me just shift the gear a little bit and start with you, Alfredo, right? From the user perspective, what my cue card tells me that where do you see the highest value use cases for AI today? Is it in the operational automation, customer experience, security, cost optimization, or new revenue creation?
Yes,
To all.
all of them. Right, so obviously at Sabre, we're building applications to meet our customers' AI needs, right? And building those MCP servers so that they can start serving those insights to our end customers. But internally, we're using it in incredibly diverse ways as well. For our own internal operational AI, we're trying to understand, we have some migrations from legacy systems into new open x86 systems. We're using AI to translate code in real time there. I don't think there's an area of our industry that AI isn't touching and touching in a very meaningful way. Even I would say underpinning that is the ability of the MX and the Trio chipset to really do all that at a secure scale. Even though it's not an AI directly related thing, we've been using MaxSec on the MX platform for over 8 years. So in order to be able to continue to do that, to support the bandwidth and the throughput that AI is asking for, and continue to do that MaxSec that's post-quantum capable at line speed is an enormous force multiplier for us. So to answer your question shortly, I don't think there's an area of our organization that we're not seeing that value and that potential from AI.
Awesome, thanks. Eachin, if I can come back to you, ask you the same question, but not from Microsoft perspective, but from your end customer perspective. What is your end customers asking you as they build their AI infrastructure, where the value creation is for them?
So there are two ways to look at this. First is obviously how we can enable the customer workloads. As I said earlier, AI completely changes how the WAN traffic distributes. Historically, if you look at wide area network traffic, it is TCP driven, maybe a little bit of UDP streaming traffic, maybe a little bit of QUIC. But essentially all those protocols can handle themselves and then fix themselves if there's something wrong. With AI, it's different. Just think of hosting a customer that hosts a large set of GPUs for inferencing. Now, they do not consume the inferencing, the results of the inference within our network. The result of the inference goes back to the customer network or goes back to the user. And the real-time demand just increases, I don't know by how many folds. AE mentioned earlier during his talk that this traffic cannot be cached. You have to deliver it. The demand increases has a huge impact in terms of how do we do the capacity planning, how do we place the load entirely, how do we design the data centers even, right? All those things becomes extremely important as we walk through our big customers. You probably all know that we have several big, very, very big customers in order to help them maximize their workloads, maximize their revenue opportunities. That requires us to work with them very, very, very closely, right? And then internally, we want to leverage AI as a way of, for example, improving operational capacities, efficiencies, right? The workflow orchestration is something I think AE and then I forgot the lady's name also mentioned earlier, but I'm not going to dive into that. I just want to say, underline that yes, this is happening and this is demanded out of us. So.
Thanks, Yichen. Let me shift back to you, right, Francis. What kind of a connectivity demand? Now, this is not in the cue card. This is my question. Open-ended question. What kind of a demand you're seeing from the connectivity perspective? You heard that there's not enough connectivity, but are you seeing the remote data centers, micro data centers, and demand for that also in your connectivity requirement you're getting from your customers?
Yeah, I think the neoclouds are asking for connectivity. Everybody just wants more bandwidth. That's the big thing. Recently, we went out to the data centers, and we didn't put a 1 gig port into the data center, and our salespeople were concerned that we didn't have 1 gig. So we have 10 gig, 400 gig, and 100 gig. And what's outselling right now is 100 gig. So the demand is there, right? In the data center world, bandwidth is going to be king. People want more bandwidth. So they're going after 100 gig ports, 400 gig ports. So that's a change. We're seeing the change.
Thanks.
And that's from the enterprise.
Okay. Coming back to you, Stephen, right, from your perspective, you're a leader in the cloud era, right? You help doing a lot of stuff in the cloud era. Does that infra helps you today to scale in the AI world? Or are you able to reuse some of that to expedite some of this requests from the end users?
Yeah, I mean, we're definitely leveraging it on our decision-making process, right? Part of capacity planning, also part of our diversity planning. We have a simulation model that can factor in router faults, fiber cuts, DWDM failures, and ultimately give us some predictive insight as to where traffic is going to reroute to. Is it going to be suboptimal? Is there going to be performance degradation? Things of that nature. So highly usable there. Even in remediation efforts, troubleshooting, we're using it extensively. We have some 4,200 sites globally, with network presence that we're maintaining, and that's a lot of field technicians and hands and eyes that are, replacing hardware or troubleshooting connectivity. And we have a chat bot. They're able to, essentially phone in and ask questions and report back, and then we're able to prescribe, what the next action should be. So a lot of value in whether it's operational excellence,
for the continuity,
customer experience, our planning process.
Okay, thank you. Let's move on to the next one. This is a common question for all of us, right? This is probably a wish list for all of us, right? That what do you think needs to be done where the hyperscalers, cloud providers, enterprise, and service provider can work together to make this better and faster, right? What is our expectations? And also relate this back to the vendor expectation from your perspective. We can start from that side this time. Why don't we start with you, Hannah?
Could you repeat the question? I'm not heard.
The question is, right, as a collective, right, we have the hyperscaler on the table, we have the cloud provider, we have the enterprise and the consumer and the service provider all on the same table. How we can work together to build this ecosystem faster, quicker, and better? What is our expectation from the other parties, from your perspective? As a service provider, what do you like to see from the hyperscaler? What do you like to see from the cloud provider? And what you would like to see from the enterprise in terms of your request and ask?
So at least to turn it around, I think the most important thing for the enterprises is a digital experience, right? That they can consume the network digitally. Therefore, that means standard APIs across the platforms, right? So that everybody can work together, right? So you don't want to have snowflake APIs all across the networks.
Open standards.
How do we get to standards? I think standards is really important across all of the network things around OpenZR Plus or any of those technologies so that they become interoperable, right? So that's where I see it.
And just to follow on, what is your expectation from vendors like HPE, right? What do you expect from us, right? How we can help?
I mean, I think we've got all the tools, right? So telemetry, BGPLS, right? How do we, all of those things become the key things. Self-driving network is about the acquisition of data. That's it. You can't analyze something till you acquire it. So we got to get better at acquiring the data. I would say back to the vendors, that's what we need you to do better, right? Standardize your telemetry, standardize your models, right? That would help us, everybody do development against one model, not 2, 3, or 4. Same thing, APIs. Optimize development for us.
What about from your perspective?
I think the biggest thing that we see is a little bit of a hesitance by the enterprise space to really understand how to build and scale agentic workloads, and then to be able to figure out, well, if I build it and I scale it, where do I need to manage my capacity? So there's a huge focus on capacity and a huge focus on maybe shadow IT, right? What are people building where? How do we understand it? How do we build frameworks and platforms that allow our teams to build these agentic workflows in a scalable way that allows us as infrastructure teams to support them and stay ahead of their needs, right? And ultimately stay ahead of our customers' needs. So I think there's still some maturity that needs to happen. There's certainly a lot of coalescing of standards. I think we've had MCP out for a while now, A2A out for a while. But it's going to take a while for that ecosystem to settle down. And any help really by HPE to drive that conversation and arrive at some sustainable platforms to build, scale, govern, and secure AI workloads is going to go miles in these industries.
Just to follow on that, what Deepika just shared, right, in terms of the AI automation, something you think that will be useful to automate your network operations?
Yeah, absolutely. I think those kind of efforts will go a long way and something we'll definitely be looking at, right? But it's also about the broader ecosystem. What are your customers expecting from you on what protocol? And what are those protocols going to drive in terms of infrastructure consumption?
Awesome.
I think we need to be able to operate networks better with ambiguity. We don't always have all of the custom requirements up front, whether it be diversity, whether it be latency, whether it be capacity. And there needs to be an infrastructure in place that's able to adapt dynamically to whatever those needs may be, right? If you need to pivot and build something later, it's going to be too late. I think most of us are probably very good at deploying net new infrastructures, right? But then modifying it because you got something wrong, it was dimensioned, less than what you needed. To be able to, rapidly accelerate that deployment and right-size it is something that we as a whole industry need to improve on.
Thank you. Kishan?
Yeah, Steve said it very well. That's one of the things I want to say as well. We do work with our customers a lot, and for the very meaningful purpose of having the capacity being fungible for future needs, and then being fungible to, or being more responsive to failure scenarios, right? The static capacity planning is well known, and we work with our customers very closely on that. Where to put the storage, where to put the CPU, where to put the GPU, what that means to the network. The next step is, how do you anticipate failure? How do you anticipate future needs so that you make a network be more flexible to that? These are the working together pieces that, I think both of us, both our customers and us, be beneficial from that.
Awesome. I have a lot more cue cards and a lot more questions. Unfortunately, we don't have much time. So I'll end with one question, right? It will be a very simple and loaded question. Do you trust AI?
What is that mean?
Yeah, let's start from.
Yes, absolutely. And I would like AI
We need
to
a applaud on that. Yes, we do trust AI.
and we want AI to do more. I just maybe say very quick words, right? I believe networking is a combination of engineering, science, and an art. Engineering part, AI does them very well. Science part, AI has shown lots of promise. The art part, I'm not as sure. I would like to see more and more along that side to help us run the network better.
Yeah, so I would say, AI is definitely helping us work more effectively, right? It's helping with a lot of the analytics and decision-making process, but the saying goes, trust but verify.
Verify.
Yeah.
Yeah, I'd echo Steve's comments, right? It's just another tool, like any other set of tools. It's maybe the most transformative set of tools we've seen in our lifetime. But there'll be a period where we understand how these tools evolve better. And in the meantime, we're going to have some guardrails until individual organizations get that confidence and get their tooling straight to understand how to utilize them in the best way and safest way possible.
Thank you.
I would say I would leverage AI. I think it's amazing, but it needs to be verified every time. It hasn't gotten trust yet.
Yeah, no, very well said. I think, thank you very much, guys. I think it was very interesting and very different perspective, right? Because you have a hyperscaler, cloud provider, an enterprise consumer, and a highway builder, right? AI highway builder. Very, very different perspective, right? From a different position where you are in the market, right? And your leaders, what you do, right? So thank you very much for your time. We really appreciate it, right? Thank you, Chen.
Thank you.
Thank you so much. Right.
Thank you. Absolutely. Thank you.
Hey, you can stay on the stage for a minute.
Thank you.
Thank you very much.
Thank you.
With that, I'll give it back to the AE to do the final close. Thank you.
Thank you, Sunil. In case you guys missed the last question, he asked, can you trust AE? So you can trust him, so definitely. What I have for you guys is one more slide, and then we'll wrap it up. For flexible consumption of our devices, we have bundled HP Financial Services. It does two things. You don't pay just when you buy it. You actually start paying when you deploy it and make things happen. So I want to leave you with that thought because we have partnered with them to do that. The second aspect that HP Financial Services does is a complete lifecycle management. As AI is transforming your networks, you need to be able to take out your old equipment and recycle it properly. These guys do a tremendous job of building that and making that happen. Wanted to make sure that you have that in your toolkit to make that happen. And last but not the least, we have the momentum. It's building, and we would like to take advantage of this. We have the strongest products and the strongest solutions. You heard from the customers. You heard from every one of us. We really love to make this AI era as great an experience as you can think of. Thank you, everyone.